In this video, we will talk about BGP Basics and Applications, guys. BGP, the Border Gateway Protocol, is the protocol used to exchange routing information between different autonomous systems most of the time on the internet. So it determines the best paths for data to travel across interconnected networks. So mainly, guys, it will operate between different autonomous systems, but there are some use cases it can operate within the same autonomous systems as well. It uses attributes like AS path, next hop, and prefix length to select the most efficient route. BGP handles large and complex routing tables and essential for the global internet. So in summary, BGP is critical for internet routing, managing the exchange of routing information between diverse networks to ensure efficient data delivery. By the way, guys, BGP uses TCP and port 179, and it is the dynamic routing protocol with the slowest convergence time. Again, as I told you, the main purpose of BGP is to perform routing between different autonomous systems without loop. So routers in different autonomous systems establish BGP peering sessions to exchange routing tables, and this is often done through eBGP, external BGP protocol. BGP uses a path vector mechanism to keep track of the AS paths a route has traversed. Okay, so each route advertisement includes the AS path attribute, which lists all AS the route has passed through. So many different parameters can be used for BGP path selection, but guys, if none of these parameters are configured, BGP behaves like RIP and decides on the number of hops passed. The hop count means the AS number in terminology of BGP. On the screen you are seeing mainly two paths from left location to the right location. On the above path, you are passing through three different autonomous systems to reach the location on the right. On the below path, you are passing through only two different autonomous systems. So by default, if you don't configure anything else, BGP will consider the below route as a best path because that is passing less hop count, I mean the AS. So BGP has three different tables mainly. BGP table, it contains all routes learned from BGP peers, including path attributes and AS paths, and it helps BGP to determine the best routes, but is not used directly for packet forwarding. We have the neighbor table, which stores information about BGP peers, including their IP address, AS numbers, and the session state. It tracks the status of BGP connections with other AS. And the routing table, the main routing table used by the router for packet forwarding, as you know. So it contains the best paths to destinations based on various routing protocols, including BGP, and determines where packets should be sent. And we have the BGP message types. They are very much essential for establishing and maintaining BGP sessions between routers. So there are four different message types. Open initiates a BGP session and establishes parameters like BGP version, AS number, and hold time, and it contains information to establish the BGP connection and negotiate session parameters. Keep Alive maintains the BGP session by confirming that the connection is still active. Okay, it is sent periodically to ensure that the BGP session remains open and to detect session failures. On the other hand, update advertises new routes or withdraws previously advertised routes. Here it includes route information such as network prefixes and path attributes. So it updates the BGP table with route changes. And lastly, we have the notification type, which alerts the peers of errors or issues that require the BGP session to be closed. So notification contains error codes and descriptions to indicate the nature of the problem and terminate the session if necessary. So in summary guys, BGP uses open to establish sessions, keep alive to maintain them, and update to exchange route information, and notification to handle errors and close the sessions if needed. Alright guys, we are coming to end of this session as well, and thank you so much for listening to me.